Hi, and welcome to this first video in the series on integration. And before you get into these videos, you need to make sure you've looked at differentiation. And the reason for that, as it says in the title here, is that integration is the reverse of differentiation. All mathematical operations can be reversed. For example, the opposite of multiplying is dividing, the opposite of squaring is square rooting. We can undo trig functions. Integration is a way of reversing the process of differentiation, so you need to have understood that process first. And if you're happy with that, you got it, let's just crack on and have a look at what we're going to be doing. So first part is looking at the actual method behind integration, and then we're going to be looking at these things called indefinite integrals and introduce an idea that's called the constant of integration, and then move on from indefinite integrals to something called particular solutions. Okay, so here we go. This first video, we're just going to look at those first two bullet points, the mechanics of how you actually go about doing the integrating and what this idea of a constant of integration is. So, let's crack on. We're going to start off by looking at differentiation, just reminding ourselves how we physically process differentiation. And it's a two-step process because, we take our original power, then we say we multiply by the power or bring the power to the front, then take one off the power, and that's the result that you get, and that's hopefully we should be familiar with. Now, if we're going to say that integration is reverse of this, we're simply going to basically do this flowchart in reverse. So what I'm going to do is start off with my standard polynomial function. There we go. And so the first thing to do is to reverse that process. So that's clearly going to be add 1 to the power, and then reverse that process there, which is dividing by the new power. And what we end up with is an expression that looks like that. So there's the add 1 to the power, and there's the bit that's dividing by the new power. Now let's just have a look at a quick example and see that what I'm going to do to begin with is differentiate it, and then I'm going to reverse it and get back to where I started from, just to prove that the one process is the reverse of the other. So we've got this function here, find f dash of x, which is the differential, and so differentiating it, hopefully we're happy, we're going to get 3x squared minus 10x minus 3. So just take a moment to have a look at that and make sure you're entirely comfortable with it. And then what we're going to do is go back the other way. So we're going to integrate this function here, f dash x, and that's going to get us back to our original function. So let's look at each bit in reverse. So we're going to start off with, to get to f of x, we're going to start off with this one here. And so we're going to add 1 to the power. So add 1 to the power, and then divide by the new power. So the new power is this. So there we go. Divide by the new power, so we divide by 3. That's that bit done. We're going to do the tidying up in a minute, so we'll just go on to the next term, which is this one, this minus 10x again. So we've got add 1 to the power, so this is power 1, so that becomes power 2, divide by the new power, and then the minus 3. Now, here's the interesting thing. Well, 3 on its own, we could write that as, I said over here, 3x to the power 0, because x to the power 0 is 1, so adding 1 to the power just gives us x to the power 1. Divide by the new power, we've got to divide by 1. Okay. Now, the only other thing you'll notice is that my original function up here was x cubed minus 5x squared minus 2x plus 4, and we ended up with a differentiated function with fewer terms because we know that the 4 just disappears. And the question we've now got to ask ourselves is, well, how the heck do we get that constant term back when we're integrating? Because we've got nothing there, we don't know anything about it, we don't know what number it is. It's just because it disappeared when you differentiate it. So how do we get it back? Now, as it turns out, if we take this function here, I could have put absolutely any number at all on the end here and ended up with exactly the same function. So the problem is we don't really know what that number is, just if we start off with this. So what we're going to do is include what we call our constant of integration. That was the thing I was talking about earlier, and say, okay, well, to begin with, we're just going to go, okay, we're going to call it plus c. So when we integrate this function here, we've got our integrated function plus some number that we don't yet have enough information to be able to figure out. So that's the thing that's called the constant of integration. And it's important when you're doing these things, and this one is what's called an indefinite integral, it's important that you make sure you remember to include that plus c, that constant of integration. Okay, so what we're saying is to integrate, that's the notation we're going to be using. So I'm just going to go through all the different bits and pieces we've got up here. The first bit, this big kind of long S sign, just means we've got to integrate. This is just notation here. That just means we're going to integrate with respect to x. That bit is more important when you get onto integrations and bits and pieces next year. But for now, it's just a notation issue that you just need to remember to just to plug in. And there we've got the add the 1 to the new power, divide by the new power, and then we've got the add the plus c on the end. Okay, so let's have a look at some examples. Starting off with a fairly simple one, and as you can see they're going to get a little bit more scary and horrible as we go through. But let's start off with the easy one. There it is. 4x to the power 5 minus 6. So what I'm going to do is integrate that with respect to x. So what we're going to do is add 1 to the new power, add 1 to the power, that gives me 4x to the 6, divide by 6, and then I've got the minus 6x, and then I've got the plus c. Now, here's the thing that we just need to make sure we're noticing is that I'm integrating here, so I've got this integration symbol here, which means I've got to integrate this with respect to it. Here, I've done my integrating. I no longer need the integral symbol. I don't need the dx thing. This tells me I've got to integrate. Over here, I've done my integrating. And it might be you look at that and say, well, 4 over 6 would become 2 over 3 if you asked to simplify it. I haven't done in this case, but obviously you can do. Right, on to the next one. This is where we've got to start doing a bit of fiddling around before we get going. And the two we're going to have to fiddle around with is this term here and this one here. So let's have a look at what we're going to do. So that's our function that we're going to integrate with respect to x. And we're going to take that function there and say, well, we're going to write that as x to the power minus 2. And the root x we're going to write as x to the power half. So same as you did for differentiation, we've got to get these things written as powers of x before we start doing our integrating. So the expression I'm going to integrate is that thing there. Now I've got it all tidied up in the way I want it. Now I can do the integrating, so here we go. So we'll start off, add 1 to the power, divide by the new power. Here, 5x to the half, add 1 onto that, 1 half plus 1 whole, that's 1 1/2, or I prefer 3 over 2, so we've got 5x to the 3 over 2 divided by 3 over 2. And then here, we're going to add 1 to the power, so that's going to become power 3/4, and divide by the new power, which is, I'd say, that 3/4. And hopefully you'll see, as soon as you start integrating fractional powers, you're going to have to get fairly comfortable with dealing with fractions, and particularly dividing fractions. And the whole idea of, for example, here we're going to turn upside down and multiply. So let's just have a look now at what we get when we tidy it up. So I've got 3 divided by minus 1, so that's going to be minus 3. So I've got minus 3x to the power minus 1. Here I've got 5 divided by 3 over 2. KFC, kick, flip, change, turn upside down, multiply, so that's going to become 10 over 3. And then here I've got 2/3 divided by 3/4, flip it upside down, that's 4 over 3, do the timesing, I've got minus 8 over 9 to the power 3/4. And then the final step, what's missing? Well, clearly it's the plus c. And then you'll notice I don't need to put the plus c in over here, we just include that when we've done all the integrating, tidying up, and just put it in as the last thing we do. Okay, so moving on, let's have a look at part C. So we've got this one, so it's a division. So again, what we're going to do is do the division first and get these written as individual powers of x. So I've got 2x to the power 4 divided by 4x squared. So I've got 2 over 4, which is a half. X to the 4 divided by x squared is x to the power half. On this term here, we've got minus 5 over 4, x squared over x squared. And here we've got minus 3 over 4. And we've got an x squared on the bottom. And that x squared on the bottom clearly becomes power minus 2. So just take a moment just to have a look and make sure you're happy with where I've got all those bits and pieces from. And now we're ready to do the integrating, and off we go again. So here we go. Add 1 to the power, divide by the new power. This one here, this is our constant. This is 5 over 4 x to the power 0. So that's going to become x to the power 1, just x. And here we've got x to the power minus 2. Add 1 to minus 2, we're going to get minus 1. So we've got 3/4 x to the minus 1 divided by minus 1. Do the tidying up, half divided by 3, that's going to be 1/6. That one I don't have to do anything extra with, that's just as it is. This one we've got to be a little bit careful, because we can see we've got a minus and a minus, so that's going to become plus 3 over 4 x to the minus 1. And finally, the plus c. And then now for the last one, here we go. So let's do the dividing again. So there's my function, do the dividing. Notice here I've got my integral sign. I've done some tidying up here to get it in the right form. I've still got it because I haven't done the integration yet, so I still need that integral sign and the dx. Now I'm going to integrate, so the integral sign is disappearing because I'm doing the integrating. So we've got 5x squared over 2 minus 3x over 1, and here add 1 to the power, so that's going to become minus 2x to 0 over 0, and straight away now we can see we've got a fairly major problem. And the problem with that is divided by 0 is undefined, so 2 divided by 0 just physically doesn't exist. X divided by 0, that's power 1, so this thing here, 2 divided by 0, just means we can't do that, so we cannot at the moment integrate anything that's to the power minus 1 yet. We will be able to get around it, but it involves a bit of sneaky maths and something a bit out of left field, a bit different, and that's something you'll come across when you get into year 2. So for now, don't worry about it. If you end up trying to integrate anything to the power minus 1, it becomes undefined, you can't do it, chances are you're not going to have to deal with that kind of thing in any year 1 questions or exams. So there you go, that's it, that's your integrating, the basics of integrating done and sorted.